Okay, now we're going to look at this skill work involved in 5.1. And if we have two different equations, we have two different variables. You can solve, you can graph those lines and figure out a solution, just like I showed you in the intro video. If you haven't watched that one, make sure you check it out or read through the book. The equations usually come from some kind of word problem that we're setting up, just like you did in chapter 4. That's why we do that first. So you have to look at all the relationships and how they fit together. Now we're adding in a new thing, like we're actually going to set them up as two different equations rather than kind of making it all be in terms of one variable. We're going to label them as two. And you'll see in the word problems, they'll look really familiar to you. So that's the idea of it. Now let's get down to the nitty gritties here. So we're going to graph. Okay, we're going to first graph one line, connect the dots. Don't forget to do that. I did notice some of you aren't always connecting dots. Definitely have to do that on this. And we are then going to draw the other line and connect the dots. And we want to make sure we label those lines. Now, if they intersect, then we're going to have that be the solution, just like I showed you in the intro video. So if they intersect, that point is the solution. Okay, so we'll have an XY value that works. Now, if the two lines do not intersect, that means they're parallel. They're going to have the same slope and different y-intercepts. So that means they'll never cross. So there's going to be no solution for that. And then solution 3, if they're actually the same line, then they will overlap. So one line can be a multiple of another. Like say if I had, y equals 2x and I have 3y equals 6x, if I went to graph those, they would actually be the same line, right? Same line. Because they are not only parallel, but they have same b value, right? So we'll take a look at some of those things also. So I changed how I wrote that just a little bit. Same line, since one is a multiple of the other, they have the same slope and y-intercept. So that's the last scenario that we'll get. So then you would say infinitely many solutions if they're the same line. So make sure you actually answer the question in that way and don't just graph it and leave it. You have to actually give a solution in like either written as a point, saying no solution, or you could say, sometimes I think in your electronic work it says, right, DNE for there's no solution, does not exist. Then also for coinciding lines, you would have infinitely many solutions, and they might just have you put an infinity symbol in there. So just double check how they want you to mark that. If it's a word problem, you'll be writing out a sentence and interpreting the meaning. So now we're on page 56 of your workbook. The first thing we're going to do is just look at how we would verify a solution. So we're going to be given a point, and then we want to see, well, does that fit both of these lines? As soon as you have a situation where it doesn't work for one of them, then you're done. It's not a solution. It has to actually work for both the lines. That's the sweet spot, the point of intersection that I showed you earlier in the graph. So think about that. You could, graph these. That's what we're going to do eventually. And then you'll get a point, and then you would plug it back into each equation, that same point, and see if the sides balance, just like we do when we have just one, when we were graphing one line. It's the same process. You just have to check them in both. So I'm going to do one of the checks, and then I'll have you do classwork, pause it for the other check, or you could do that for both of these and then just see if you're right. You can kind of go quicker through this. So now we have what I've written out here, 2x plus y equals 2. So I'm just picking this first top one, we'll call that equation 1. So we're going to test equation 1. So I just rewrote the equation there, and then I'm picking 1 point to start with, and I'm going to plug that in and see if it's true. So remember, does it equal, right? So then I end up getting -4 plus 3 equals 2. And then I get -1 equals 2. So I should put a does that equal 2? Well, no, it does not. So then we would write not a solution. So right away, we know this point can't work. Even if it were to work in the other line, we could test that. We could pop that in. We'll check it in that one. 4 times -2 minus 3 times 3, does it equal 9? -8 minus 9, does that equal 9? Obviously not, right? So we can put that not equal to. So no. But my point is that if it fails here, it fails all around. Okay. So this one fails. So if it fails 1, then total fail, right? It just that point's out. Now we're going to check the other one here, 3/2 and -1. So we're going to check that in the first equation and then the second. So why don't you do that one as classwork and see how that goes? All right, I've plugged in my 3/2 and my -1 into this top equation, and I got that 2 does in fact equal 2, right? So that's all good. And so far it's a solution, but we can't say for sure until we actually test it in this other one. So we got to bring this one down and test it in there. So we're going to do 4 times 3/2, testing this point, minus 3 times -1. Does that equal 9? And then we can reduce, and then we will get 6 plus 3. So remember, negative is positive. And we get 9 equals 9. Yes. So therefore, these 3 dots mean therefore, we can say that the point 3/2 1 is a solution to this system. We'll just abbreviate. So it's called the system, or system of equations technically, but we always abbreviate system, just kind of shorten that up. So that is our answer would be this one, 3/2 -1 is a solution, but the other one is not a solution. Okay, so we have 2 answers there for this problem. Okay. Okay, now we're going to actually move this up to, we are on page 56, and it's the second problem. Okay, so we're at a point now here where we're going to graph these 2 lines, and you guys are getting really great at that. So let's go ahead and pause the video and try it. If you want to just follow along with me, that's fine, but I encourage you to pause here, graph each line separately, and then see where they cross. Okay, so the method I'm going to use here is just a quick table graphing. I'm going to plug 0 in for x and find my y value, which would just be 1. And then I'm going to plug 0 in for y and get my x, which would be 1. So I have 2 points. At this point, you can kind of streamline your graphing process. So I have 0, 1, and then I have 1, 0. And I can connect those dots. I may want to get a third point. Maybe I'll just pick, I don't know, I think I'll pick 3 so that I get a bigger spread. And if I just do 3 plus y equals 1, I'm going to then subtract 3 from both sides. Y equals -2. So I'll plot that one also, and I can tell it's right in alignment there. And then I'm going to make sure that I connect those before I move on. Okay, so let me get a line here. I want to extend that down. It's kind of a new thing for me here. So, using this little arrow. I mean, so this line, actually, it's a line function and it doesn't have the arrows. So I'm going to make sure I get those on there because it will extend. We did not restrict the domain on this. So this is equation 1. So I'm going to label it there. Usually I just call the first one equation 1 and the second one, the one underneath equation 2. So now we're going to do the next one, and that will be similar process. I can just put 0 in for x, and I would get 7 for y. And kind of do a lot of these in your head here. If I put 0 in for y, I'm going to end up getting a fraction here, which is fine. But if you're not comfortable with that, because then it's hard to plot, just pick another x value and see how that works. Like maybe let's pick, if we already have 0, 7, let's go ahead and plot. That's kind of high too up there. Let's pick, if we had x equal to 2, then what would our y be? I would have -2 times 2 plus y equals 7. So that would be a -4 here. So I would add to both sides. So that's going to bring me higher even up here. So I probably don't want to go that route. I think what I'll do is actually go negative on this one. Well, I'll just do -2. I think that'll work out much better. So I'll have -2 times -2 plus y equals 7. Then I'll get a +4 here, subtract that from both sides, right? And then I would get a 3. So I have the point -2, and I have +3. I see it right there where it's going to cross. So as long as we have a couple points that we're comfortable with, and we also had our 7 halves, which we would just could put into a mixed number or decimal to help you figure that out. So you could also do that one would be -3.5, 0 for the x-intercept. So not too bad. We should probably plot a couple points on these as well. So once I graph this line, I'm going to do that. So make my arrow here, I'll make a line, and then I'll wiggle that over a little. All right, so that is my second line, equation 2, and you can see right where they intersect. I mean, in a perfect graphing system. Let me put this bigger. Then, if I were doing it on a computer, it would be perfectly lined up. I also want to graph or just plot a couple points on my graph where I had that 3, -2. I can also label my 0, 1, just a couple points on each, especially this one where it's off the grid a little bit, and this one where it's a fraction. It's good to label. But now I really want to make sure I put my answer in there. So my answer is -2 and 3. Okay. So, and I really didn't know that when I was picking this. I just kind of randomly did that, but sometimes you can just see it right in the table. So you would just label your answer as such, just so I know which one is which for sure, okay? That's really important. Okay, so now moving on to page 57, there's a couple more problems to try. These are going to be classwork. So pause, then check. Okay, so you'll need to see the graphs and then make sure you have the right solution. And then you can just check back and see what happened. I talked about something earlier at the beginning about some different cases. So just think about, like, as you're doing this, it might look a little strange at first or seem strange, but remember there's different kinds of ways to write your answers. So just get the graphs done, and then if you're not sure what to write for an answer, we can talk about that again. Okay, so here's my lines. Sorry, this one's a little off. I'll try to adjust that. We have our two lines. We have parallel lines. I did label the points, so you can see usually we label the intercepts. So this one is equation 1. This one's equation 2. You can see that they are parallel, so they'll never intersect, right? So we are going to say no solution. Okay. Moving on to the bottom of the page. Actually, before we do that, I want to show you something here, how I solved this. I used the slope-intercept forms. I rearranged them. Be careful with your negatives on that first one. And I notice here that I have the same slope. So if I look here, I have a slope of 1, the same slope, but I have different y-intercepts on those. So I actually don't even need to graph it, right? I know they're parallel lines. You guys have worked with parallel lines a little bit. That's one reason why we wanted to take a look at that. So we can just answer the question right off the bat that there's no solution based on the fact that they have the same slope but different y-intercepts, therefore are parallel lines. Now you might notice something interesting with the second one as well, and you may not necessarily need to graph it. You could certainly do that to check, and also you should do it for practice and graphing, and if I require that for a quiz question or a test question and say graph the lines and you don't do it, then you won't get full credit. But if I just say solve this and you can figure it out, that's different. Or it's like giving yourself an extra check point as well. So let's go ahead and rearrange this equation, the top one here, and we will write it as y equals 5x plus 2 for equation 1. And then equation 2, I'm going to rewrite as 3y equals 15x plus 6. And you can kind of see something happening. If I solve out for y here, get y in terms of x and put it in slope-intercept form, right off the bat, I see that these two lines are equal. So they're actually the same line. The second one is just a multiple of the other. So when we go to graph that, it's pretty nice, right? We can just quickly plot the points. We have a y-intercept of 2. We have a slope of 5. So 1, 2, 3, 4, 5 over 1. We got to kind of judge there. And then the exact opposite, I can go down 5. 1, 2, 3, 4, 5 over 1. Well, I feel like this solidifies people's graphing skills in this section, which is really nice. So remember to label a couple of points. So I would have -1, -3 there. Okay. And then don't forget to connect the dots. Let's see how good I can do. Get my line in there. All right, perfect. And then, well, not quite perfect. Um, and then we're going to add the arrows because it does continue on. And then don't forget to answer the question that you would say infinite number of solutions because all the points match up. It intersects everywhere. So it's not necessarily you would say all real numbers, but you would say there's multiple, infinite number of solutions. So we just write infinitely many solutions is one way to write that. You'll see it, a variety of ways too. So, and that is the answer for that one. So thanks for watching and have a great day. I'll put the other sections up later.